Imagine a room. It is incredibly clean. Cleaner than any doctor's operation theater. The air inside is filtered again and again. Even one tiny speck of dust is like a giant boulder. It can ruin the delicate work being done. This special place is a semiconductor chip factory. It is where modern magic is made. What exactly are these chips, you ask? They are like tiny electronic brains. Semiconductor chips are truly everywhere. You find them in your mobile phone, in your computer, they are in your car, and in your television set. Even your simple washing machine might have one. They are the unseen power making our modern life work. Without these tiny marvels, our gadgets would just be empty boxes. They are fundamental to almost everything we use. These chips are absolutely vital for today's world. They process information at unbelievable speeds. They connect us to the vast World Wide Web. And one small island nation is a true giant in this field. That island, my friends, is Taiwan. So, how is one of these amazing chips actually born? It all begins with an idea, a design, like an architect's blueprint for a massive building. But this particular blueprint is incredibly mind-bogglingly complex. It contains millions, sometimes even billions of tiny parts. Every single part must be placed perfectly. These parts are tiny switches known as transistors, all arranged in very precise and intricate patterns. A universe of detail on a tiny speck. Who dreams up these fantastic and detailed designs? Many well-known technology companies do, actually. Think of Apple, the company behind your iPhone. Think of Nvidia, famous for powerful gaming graphics cards, or AMD, known for its high-performance computer processors. These global companies meticulously design the chips, but often they do not build the physical chips themselves. They are what we call fabless, meaning they have no factory. So, if they design them, who actually builds them? This is where companies like TSMC in Taiwan step in. They begin the manufacturing process with something very common. Believe it or not, they start with sand. Yes, ordinary beach sand. Now the real manufacturing magic starts to unfold. This stage involves a process called photolithography. Photo means light, and lithography essentially means writing. So, it is like writing or drawing with light. The complex chip design is shrunk down many times. It is then projected onto the surface of the silicon wafer. This is done using very special ultraviolet UV light. Think of it as a tiny, super precise slide projector, but on a scale that is almost unimaginably small. Before the light projection, the wafer is carefully coated. It is covered with a light-sensitive material called a photoresist. Where the UV light hits this coating, the material changes chemically. Then, specific chemicals are used very carefully to wash away certain parts of this light-sensitive coating. This process reveals the bare silicon underneath in precise patterns. Next, other chemicals or gases are used to etch the silicon. This etching carves the chip's intricate patterns into the wafer. It is a dance of light and chemicals. A modern semiconductor chip is not a flat single-layer thing. It actually has many, many different layers, like a very complex multi-story building. The pure silicon needs a few more important changes. These changes are needed to make it a proper semiconductor. This crucial step is achieved through a process called doping. In doping, tiny controlled amounts of other elements are added. Elements like phosphorus or boron are often used. These added elements are technically impurities, but they are introduced into the silicon very, very carefully. Their presence changes how silicon conducts electricity. It is a fundamental step in chip creation. Doping helps to create different specific areas on the chip. Some of these doped areas will conduct electricity very easily. Other areas, doped differently, will conduct it in another way. These are often referred to as N-type and P-type silicon. This precise control over conductivity is absolutely vital. It is what makes the billions of transistors work correctly, allowing them to switch on and off billions of times every single second without failing. The speed and reliability are astounding. Making these advanced chips is an extremely hard task. Many things can go wrong at any stage. The silicon wafer is now completely processed. It is full of hundreds, sometimes thousands of individual chips. These chips are usually tested while still on the wafer. Then the wafer is carefully cut or diced. Each tiny chip or die is separated from the others. These individual silicon dice are extremely delicate. They need robust protection from the outside world. So they are then sent for packaging. This is the final stage of their creation. The chip package does much more than just protect it. It also provides the necessary electrical connections. Tiny gold wires, thinner than a human hair, link the chip. They connect it to bigger metal pins on the outside of the package. These pins are what connect the chip to a larger circuit board. The fully packaged chip is then tested one more time. It undergoes thorough testing to ensure it works perfectly. Only then is it finally ready to be used in our devices, ready to power our digital lives. Taiwan, and especially its flagship company TSMC, truly excels here. They have comprehensively mastered this incredibly complex art. This mastery comes from years of focused experience and huge investment.